Okay, so what does your school mention regarding regarding this part,
The
this chapter?
ethics.
Yes.
We went through all the basic stuff like the four nucleotides, like what is DNA made of,
Okay, okay.
you have your adenine, cytosine, guanine, thymine.
I'm trying to. Okay, so those are things that we know, right? Okay, don't worry about the. I'm trying to. Is it working? How come it's not working? Okay, don't worry about the cat. It's just something I put to cover on, like when I do streaming I don't put my face on it. So that means when I like move my head, the cat moves with me. So when I talk, the cat mouth also move. So yeah, go like ah. So yes, so don't worry about it. Because eventually when I solve questions for people online, I don't use my real don't use my name. Yeah. So yes. Okay. So you mentioned that cytosine guanine. So your school mentioned ATCG, is it?
Yes.
Okay, other things? Don't worry, you just tell me what you remember, but I'm just making a list of what we know so we can tackle things that we are not so sure.
Okay, then we did move on to the genes part, which is your wait, no, let me check my notes.
Okay,
Where is my notes?
okay.
Activation. Okay, we only did DNA, the first part.
Okay. Okay, because I think there's mainly three parts of this chapter. Number one, you have to be able to identify what does the word genes, DNA, chromatin, chromosomes, all this, how do they link together? So that's one part. Then second part is related to explaining the basic structure of a DNA, which DNA links to something called a phosphate group, deoxyribose sugar, and a nitrogen containing base, which base links to, in short, it's a bunch of molecule links together to form something called DNA. So first part talks about how DNA, genes, chromatin, all this bunch of words, right? They are like, how do they link together? Second parts talk about more towards the basic structure of how bonds like this link together. And then the third part actually talks about how all these genes relate to two keywords which you already mentioned, which is transcription and translation. Okay, so I assume since you mentioned about transcription and translation last time, did you read that part or school went to there?
No, I read it myself.
Okay. How? I mean, because eventually when everyone goes to uni, you have to learn to, how do I put it? Deal with literally open up a book and then look at a lot of words and then go sigh. Then after that you're like shit, I no choice. Then you go to read, then you don't understand. It's like wow, what the hell, man? That's like but I have to read again. So it's a process of you reading and trying to figuring out. And every one of us when we first doing it, it's like everyone is like it's like really bad. So as you read, what is the rough things you know from the from the textbook that you get?
Transcription and translation. I mean, I see the diagram of the textbook is pretty complicated. I don't really understand anything.
Okay. Okay, let's talk about things that you understand. Not understand, we just skip for now. Each other know sometimes people read book, people look at pictures, right? At least they know what the picture is about, kind of thing. So roughly transcription, translation, what do you think is, why do you think those processes are written in the book in the first place? As in, what are they related? Is that something to do with ATCG? Is it something to do with then how come DNA is so important? Like, everyone in the world just keeps saying DNA. What does DNA means? Just rough things that you might know. If don't know, it's okay. Just say I'm not sure. It's don't know. It's fine. Okay. You said one of the most important question to solve in this chapter. How does genes, also called DNA, affect physical factors? Good. Good. Okay. Yes, timing will be replaced by something. Don't worry. Okay, move on. Rough things that you know. If it's like don't have anything, it's fine. Okay, but it goes back to the first question I asked, right? How does a person's DNA affects a person's trait? Any idea? Because you did say that if this person has some different DNA thing, let's say my DNA is different from yours, that's why we look a bit, no, not a bit, we look very different in terms of certain features, maybe how the ears like, color of the eyes, etc. So for now it's basically DNA, right? First step is DNA, then in the middle is question mark, then magic, and then bam, look different. Right? Okay, any part of the question mark you could understand? Like maybe you found out or read from the book or something. Or for now it's just like, because everyone say DNA makes a person different, so it's like that lor. Is it? So basically, let me put it this way. You know what's a blueprint? So blueprint, basically, if your architect has a blueprint, they say, hey, this building built like this one, how many pillars, at what angle, how tall, how short, how fat, how wide, and then the building will look according to the blueprint. So basically, blueprint is the plan, then the construction worker, everyone, the architect and construction worker follow the blueprint and build the building. And the building is made of concrete, also called cement and metal and stuff. So DNA is the blueprint. It basically is the instruction to say how to build this thing. And this thing is you and me. Depends if it's my DNA or your DNA. The building part, the entire body, as you read right from the start, carbohydrates are meant to provide energy. What does protein do? Okay, that's one. And the other one will be repair and growth. Agree? That's why when people are younger, people always say something like, drink more milk or like eat more meat. I don't know, grow. You can grow taller. And some people even have like, what's the whole cod fish oil or something, cod liver oil, and all sorts of as long as people will always have the idea of protein is good, because protein. Okay, literally, if you use metal and concrete to build a house, that's the material. How it put it in an extreme simplicity, proteins that we eat are being tear apart into amino acids and being used to build the body. So what happened is DNA is the process that basically tells the body to get the DNA and get the protein from the food and then rearrange them in a certain way so that certain parts of the body can be made. So that the body use protein to build protein. So that our body is made largely of proteins. That's why you studied that protein is used to build and repair. So DNA is the instruction of how to rearrange the protein. And the keyword transcription and translation has to do with how does DNA go through transcription, translation, affect what kind of protein, and how to manufacture those proteins to arrange in a certain way so that ultimately whatever the result it builds looks different. So with that, let's go with a video. In between, we will pause a while to talk about certain things. They are, in this case, this video is produced actually by textbook. I think it's by McGraw-Hill, and things they say are for uni. I believe certain things are for uni. So certain things, don't panic. I will just let you know what is and what is not in your syllabus. Okay, we just look through the video first. Okay, so far it goes a bit fast. So he first said that we ate food get digested, and then body absorb amino acids. Amino acids, how amino acids is used to build the body depends on DNA. And DNA is within DNA it contains genes. So in this case, which one is bigger, DNA or genes? Sorry? Correct. DNA is bigger, and within DNA it contains genes. And the genes will basically produce something called RNA. So here I got two very big words, DNA and RNA. DNA stands for deoxyribose nucleic acid. Don't worry, we will go through that word because it's a very long word. And RNA, right? RNA is what is being made by it. RNA is made by so the body made RNA using DNA. Okay, and let me double check. RNA, so we go on from here. It basically says that from RNA that it makes the region. Okay, so continue. So basically this is part of the gene that we want to use. Promoter and terminator, the term used here is basically how you know how if you want to scan a piece of document, we put into the printer, and then the printer scanner just move by then move from left to right. So imagine now the body will use something to scan, starting from promoter region. It starts scanning and move along the whole entire long thing and stop and terminator region to produce something called RNA. What you're about to see is how RNA is about to be processed. Okay, we continue. Okay, so feel free to, as long as you pause the video, you'll pause as well. Okay, so this video just said a lot of things. So what do you understand what it just said in the past 10 seconds? Okay, if you're not sure, you can use your mouse, you click back, and then you will just replay the part. Then you pause and you explain to me. It's fine, just have fun. Okay. Actually, it should be more of, when you use the word DNA, it refers to the entire structure. The entire long length thing is called DNA. Small chunk is called genes. So basically, a long DNA can have a few million small chunks of genes. Which then you basically say that from the promoter and the terminator. So let's say they label that maybe that part is the gene to maybe control a person's eye color. Or a different part affects a person's shape of a person's ear. So different parts of the gene, he will use the word called gene expression. Gene expression literally means that gene is being used and cause a difference. No, expression is like I try to say something or my face has certain expression, then you understand what I'm doing. So when a gene is being expressed, means that part of the gene is used to build the body and cause a difference on the body. That's what the word gene expression here means. Okay, then try. Okay. So it's trying to tell you how DNA affects the final outcome of how certain body features looks. Has to go through something called gene expression. And gene expression has two types. One is called translation, one is called transcription. I want you to take note on the word you see. Transcription, it says inside the nucleus. Translation is inside the cytoplasm of the cell, which later on you'll be related to your first chapter or inside something called ribose. The ribosome. Yeah, later on you'll be related something with the ribosome. So take note that translation happens inside the cell. Transcription happens inside the nucleus. Yes, so there's this. As long as you can understand this video with these two steps, the whole chapter is done already. Translation will never happen in nucleus because okay, we go later on, they'll break down this too, because translation only happens in the ribose. Translation happens to... Okay, let me simplify. Translation is how the body makes protein. Transcription is how the body passes the message from the DNA to tell the factory to make protein. So translation happens in the factory, whereas the transcription happens inside the director room, where the director says, do this, follow, please, factory follow, and then it'll pass the message to the cell. And translation is the factory says, hey, the boss says do this, we follow. Later, don't screw up. That's literally what it is. So you are either dealing with the designer, which a bunch of bosses design how the thing should be done, that's inside the nucleus. Whereas how the factory built things, that's inside the cell, which is translation. Smooth and rough endoplasmic reticulum is helped to basically package and transport the protein. The only difference between rough and smooth is rough has something called ribosome. A ribosome is the protein factory. Right? Ribosome is the protein factory. Basically, they make proteins. But factory blah blah what, they don't know what they need to make. So they have to receive information from the nucleus to make something. And the process is called transcription. So transcription is where the nucleus tell the ribosome to do something. And then what happens in the ribosome is called translation, where how those instructions gets carried out.
So when the translation occurs, right, is the because ribosome is in the RER, so when it detached from the RER.
What does RAR here means? Okay, so in other words, if every time nucleus have to pass message and then the DNA has to leak out Then the DNA is like as if every time we build a building, the blueprint has to be cut into small pieces to give to different workers. Then we just destroyed the blueprint. So what happened is the process has to say, original copy we don't destroy. We make certain copies so that different copy can be passed to different workers to tell them to do things. The copy that we make is called RNA. The original master copy is called DNA. Yeah, you can understand it as that. So what's after this next, it will show you how DNA gets transcripted into RNA, so that RNA can be passed to the ribosome to work, to tell the factory what to make. Okay, let's go. Okay, you click. You try to pause anytime you have things to ask, okay?
You see so many things like lining up together. What?
You see the two blue ribbon thing? The two blue ribbon anything that's connected to the blue color ribbon thing is the DNA. The DNA has to be unzipped, open up, and then to be read by this purple jelly blob thing, where it will produce something called mRNA, short form for messenger RNA. Messenger literally means that these are the words of the boss. We have to send it to the factory. So DNA gets transcripted into mRNA, and mRNA gets sent to the ribosome, so that the ribosome can use the mRNA to make proteins. mRNA is formed by scanning the DNA and to form something called conjugate pairs. Let's continue to watch this. Later on, it will show you how the unzip and the formation of it in step by step. Then we discuss that. Okay? So you can see that the purple block thing now, right? Okay, pause this now. Okay, you see the purple block thing basically it's like a membrane that allows certain, you see they unzip it and then they allow something to come inside and start attaching to form the red color ribbon. You see that part? Yeah, this is called transcription and it's trying to make RNA. This is why earlier on, you say every A is paired to T, right? C is paired to G, right? Then after that you say, oh, I'm not so sure because what you said along was, I'm not so sure that somewhere in the time the T will become something. The T will become something called uracil, it becomes U. So this is actually the process of transcription. Anything with no T but U will be an RNA and not the DNA. So in like O-level questions, right, sometimes they'll ask you whether in this case is it DNA or RNA. Then you see whether something has thymine or something have uracil. U-R-A-C-I-L. Uracil. Okay, if something doesn't have thymine and has uracil, that will be considered as RNA. So imagine now the process is we form two rows, right? Okay, let me pair. It goes like A T G C G C A. So this is basically in the situation where it's still in DNA state. What do you think the opposite should be if we follow? So you can see that the connections between them, it's opposite, right? Okay, so now what I do is I unzip it. So I will do something where I unzip this and this will move away. Once this is unzipped, during my process of making RNA, I will only scan one side. So what do you think? So basically I only scan this side, let's say. If I only scan that side, what kind of RNA will I be making? I will be making T. Would I be making TT? Okay, what will I be making? Yeah, it's very good. So you'll be making U A C G C. So this is something that I will form, and this will go to the ribosome. Correct. Only this part will go back to the ribosome. So it talks about the whole initiation and termination, because once this two red thing gets unzipped, it has to zip back, or else it's like you just open up something and then you didn't restore it, and the body has no more blueprint, and then you go haywire. Next time cannot repair back. It's like, hey, last time how we built this, forgot already. No backup. We don't know that. So that's why they say that as people gets older, they kind of, with this scanning part and goes on and on and on, people actually find that as people get older, the damage, actually there's some damage done to the DNA. Body, of course, will do something to repair the DNA, but as we go older, with the ability to repair the damage to the DNA gets worse. That's actually what aging or become older means. So your body get worse and worse over time. Okay, you understand what I mean? Okay, let's, if that's the case, let's continue. Okay, you click and you can replay any part. The bottom, okay, the blue color one is the DNA, right? The red color one is the RNA. You see the RNA become U already, see? ACU, right? Yeah. The DNA, yes, agree. So you see, it's continued to, it's like a thing just move along and just build up a bunch of RNA. Then that red color move. This one, don't worry, it's not in the syllabus. So cut away things that is not needed. Only, yeah, leaving what is needed. Because that part is not needed in the protein building. So this part, if you're interested in like biotech or bio-related things as you go up like to tertiary reading, you learn about how things called also chemistry. You remember just now it said something like 3 prime and a 5 prime, and it said something numbers. Those are basically angles when it comes to certain chemistry molecules. So they will basically cut things, react with things from the 3rd and the 5th of a certain chemical molecule. Don't worry about that. That one is uni stuff or JC stuff related. And they are basically trying to tell you that as it scans, it comes out. Certain parts, those instructions, not needed to build protein. So it will be cut away so that the important part will be stick back together and get sent to the ribosome. The only part most likely gets dumped away and then get recycled by the body to make into more amino acids and comes back to the body, or eventually just get rid from the body as urea. Okay, so you notice this part. It uses the word ribosome already, and then it has nothing to do with. Okay, let's pause this part. So basically, it mentioned here about number 1. It uses the word codons. So the body produces proteins based on RNA sequence 3 in a group. We call that codons. Every 3 in the group produce 1 specific types of amino acids. In total, according to the video, we have 64 different types of amino acids. So as now you see, the ribosome unit, which is the orangey thing, attached to the starting part, because they told us that for all the codons there's a specific part called, okay, you see what happens there. This one are the codons. A basically is combination of UCAG and U from first, second, third position. Then you have different combinations. And the different combinations, continue to move on. Okay. So those are the part that tells the ribosome, hey, start here. Scan. Hey, stop here. And okay, move on to make the next one. You can imagine it that way. So every time you say start here, then the ribosome, the orangey thing, is going to come here now. This translation. So I want to highlight certain thing. They use the word translation here. Translation happens at the ribosome. And then transcription happens at the nucleus. So, in short, transcription happens in nucleus, produce mRNA. Translation uses the mRNA to produce amino acids. Okay. Okay, so now the ribosomal subunit goes scan along and then find this part and say, hey, start here. Then scan there and start. So we continue. This blue color ribbon curl up is called tRNA. tRNA, you just imagine them as a truck. They are you see, that's just now got messenger RNA, right? Messenger RNA carries the message, carries the method what to build. tRNA, transfer RNA, go scan accordingly and transfer the right amino acids to attach. We continue. So you see, if the original building is called AUG, the tRNA will be the opposite again. So as long as you get the right combinations, you will be telling the body to combine the correct amino acids together. Okay, continue. Don't worry about this. It's okay. So you can see here, this one is the endoplasmic reticulum in 3D shape. And then they package the polypeptides that it forms, then gets sent out so that they can be made into proteins or to make into enzymes or to make into whichever part the body needs that protein to be. Depends on, let's say because all these different parts of the body will have rough endoplasmic reticulum and smooth endoplasmic reticulum, right? And then what happened is they made the polypeptides. Polypeptides get packaged at the endoplasmic reticulum. Package literally means they wrap a layer of membrane. They don't want it to leak, ma. It's like you want to like send oil out or send chemical out, you have to like put in barrels and then put on the truck to get sent out, right? So they get packaged, they get sent out of the cell so that they can follow the circulatory system, which is basically the blood system, to flow to the specific part of the body that requires that protein to build or to make into something else. Vesicle, go on. Correct. And vesicle is basically the packaging for the polypeptides. Polypeptides will get put into the vesicle before they pinch off, then become a little bubble looking thing that move around inside the blood vessel, because you don't want the protein to just get spilled and spread all over the body. You want it to go to a specific part, not spread all over the body. So you learn about the whole pinch off, and then when it goes to the right part, then you'll fuse back into the membrane, right? That's what it is. So, Makes sense? So that's that. Okay, all good? Okay, so now with that basic understanding, if you take your textbook, you go to page 386. You have your textbook with you? Okay, let me... Okay, so if you look at your textbook, 386 basically wants to explain to you the relationship between genes and DNA. As you can see, genes are part of the DNA, where DNA is the long chain of the whole thing. And then DNA is nothing but just a zoom in view of something called chromatin. And chromatin, actually, it's this very long thread-like thing that gets kept inside the nucleus. So basically, this very thin thread is kept inside the nucleus, and those actually is used to store the genetic information inside the nucleus. Okay, that part makes sense, right? Okay, then my question to ask is that how is chromatin related to chromosome? Yes, okay. So you put something, you come back to page 386 later. We go to page 301. You look at the picture, you flip to 301 first. Page 301 shows you that there is a nucleus, and inside the nucleus has chromatin. During mitosis, that thread gets cloned, DNA replication. Once it replicates, you flip to page 302, it gets coiled up to become a smaller size to make it easier for the cells separation later on. So chromosome is nothing but just a chromatin thread clone, coiled up and become shortened to look like egg shape. Because you wouldn't want things to be like, you wouldn't want to transport rope. You want to coil up the rope and put in the truck. You don't want to just sit on the truck and take all the rope and extend and go, yeah, and just as the truck goes, the rope just fly at the back. You will confirm entangle and get all sorts of problems transporting. So they coiled it up for the mitosis and the meiosis process. So if next time people ask you about this, chromosome is just coil up chromatin. Chromatin, if you zoom in, we will see a bunch of proteins. We go back to page 386. You see a bunch of chromatin threads. It's nothing but just a bunch of very long things wind together by proteins. If you remove the proteins and further unwind, you zoom in to see further, you see DNA, and within the DNA, you see genes. So according to the size, smallest is genes, followed by DNA, followed by chromatin. or basically chromosomes, DNA, genes. You have to know the size arrangement. Because a lot of teachers sometimes think that this is like, this one easy, like it's the basic, everyone should understand. So they don't tell this. So students get confused what the genes, DNA, chromosome, chromatin actually means. Because when you first started in Sec 1, Sec 2, they tell you inside nucleus store genetic materials. They are being stored genetic materials in the form of chromatin. And chromatin zoom in get DNA, DNA zoom in get genes, which the genes, which you go to page 386, are this long ribbon thing, are formation by a bunch of P. You look at 386 bottom page, you see it will be like a star-shaped P, star-shaped P, star-shaped P. So that thing forms a so-called ribbon we see. And then at the end of every star shape, it always connects to something called a phosphate group that forms the backbone. We call that a DNA backbone. Basically the backbone that forms a long spiral thing. And then the other side connects to something called a nitrogen containing base. Sometimes we just use the word base. So the base of the DNA comes in 4 flavors. In this case, ATCG, which you already mentioned. Okay, which then this part you have to understand, and if you want to make notes, you have to understand the top part. It says every nucleotide, because deoxyribonucleic acid. So every small group is called nucleotide. Every nucleotide is formed by something called deoxyribose sugar, a phosphate group, and a nitrogen containing base. So these 3 points should be written into notes. Everything else is quite easy to understand. Humans are made up of proteins combined together, and proteins are made of amino acids. So in this case, how would the amino acids be made from the body? It's made from ribosome. Then how does ribosome knows what protein to make? It's informed by the mRNA. And where did the mRNA come from? Yes, transcription, which happens inside the nucleus. And that's how the entire thing of starting up by saying DNA leads to how a person physical looks linked together, which then you can all summarize to 2 words: transcription, translation. Our blood has no DNA, but okay, let's say when you say our blood has DNA, there is a few assumptions here. You see, blood mainly contains red blood cell, white blood cell, platelets, plasma. Agree? So the red blood cell, white blood cell, platelet, plasma has to be made by the body, right? And then what makes them? Amino acids. And those amino acids is used to form those red blood cell, white blood cell, platelets and plasma, so that they combine and becomes blood. So they go on. Left at one place? What do you mean? But DNA be left at one place? Oh, basically that's if you were to have a fossil, you want to. Actually, human has been trying to do that. There was, you know, a movie called Jurassic World? Yeah, Jurassic World idea behind it was they basically try to find ways to extract dinosaur DNA. As long as you can have the dinosaur DNA, you can use that as a blueprint to assemble a bunch of protein to recreate and make dinosaur alive again. So extracting the DNA literally means that they take a certain creature, find the backbone or find the legs or find certain non-dry out part, maybe that contains a little bit of blood, hopefully can extract the DNA and then try to rebuild and recreate the entire creature. the problem with DNA lies in, it's just like the COVID-19 thing. What happened is that COVID-19, when it comes to a certain surface that is hot and dry, after some time it dies. The virus just become dormant and unable to function anymore. RNA, also called DNA in this case, is the same. If it's being exposed to very cold, very hot, or very dry surface, it will damage the DNA over time. It's like trying to put jelly under the sun. After some time, the jelly will become shriveled up and the shape will change, and some of the arrangement will break, some of the arrangement will stick together. Then in the end, you don't know what is original structure anymore. So whenever we extract things from fossil, the DNA always is still there, but always severely damaged. And until today, we couldn't build anything else out from it, or else we will already have dinosaur or already have mammoth. But there is a project trying to build mammoth. They're trying to extract a bunch of DNA from mammoth, because most mammoth die of very cold. They are being frozen up. So normally the DNA is better preserved by the environment. And on top of that, there are also another project and try to reverse engineer chicken back into a dinosaur. So the concept, the basic concept of this is, body can have different genes. If the genes is expressed, we can see the difference. If the genes are not expressed, then we cannot see the difference. We should learn it under something called dominant and recessive genes. Dominant genes get shown out, right? So let's say dominant gene is brown eyes, then recessive gene is blue eyes. You and I can still have recessive genes, blue eyes genes in our body, but they are not expressed, so that we can have that gene, but you cannot see it. So yes, so the idea behind it is that as animals evolve, certain features, certain genes are not expressed, and we have to have, basically the theory of evolution says that dinosaur over time slowly but surely evolved to become chicken. So someone says, since you say your evolution theory is correct, right? Then prove to us. If you can try to turn on those genes that was turned off during evolution, then you should create back your dinosaur, right? So that's what they are trying to do. But for now, they can only create a bunch of chickens that has claws and teeth, that sharp teeth. They couldn't clone back the original dinosaur. If they could, you will hear on the news already. Correct. Yes. Correct. You suddenly have the combinations of recessive, then suddenly got blue eyes. So if you go search online, right? Wow, you have those tragic story where one black man and one black woman have one white baby. And yes, it's possible, because maybe the black man and the black woman, both family have like Akong Ama, there's like one white, one black, and then so basically you have the dominant is darker skin, and then the recessive is white skin, like fairer skin. And just because both of the scenario happens, when these two couple marry each other, the baby they produce has recessive, die, suddenly now has white baby. Then now got argument. Hey, you not very faithful to me, how come our baby like white? But it's no one's fault. Everyone's faithful, everyone's nice. It's just the hidden recessive genes get expressed. Okay, it's I think it's definitely rare, because if you study the Gregor Mendel theory only talks about the 3:1 ratio, right? First gen. Then the second gen is, first gen is half, right? Basically, there's the pure and the first gen and the second gen. First gen is homozygous and homozygous dominant and homozygous recessive breed together, right? Then you will produce a whole entire generations of what they call this heterozygous. Are you familiar with that one? This one was, oh wait a minute, school haven't taught homozygous and heterozygous. It's under heredity. Oh, okay. Heredity talks about how different traits gets passed on. So okay, black couple have white kids. Oh, I think it's the opposite. When the kids are white and then the child is black, I think. I forgot where I read that before already. It was like pretty tragic. And then no one makes. Okay, this is CBS News, so should be still okay. White baby shocks black parents. Medically possible. See, how did Ben and Angela give birth to a white daughter? So you see, there are three potential reasons. One is dominant white genes, which entered both the parents' family long ago. So the basic, not dominant, dormant. So basically, the white gene is considered recessive for a long time ago. Maybe it's a great grandma kind of thing. And suddenly the recessive genes get expressed. And therefore they get a white baby. And no one get cheated. Another situation is basically possible for genetic mutation. There's basically albinism, which you heard about things like white tigers and stuff. So there could be like, so first report the strange case rule out albinism because but anyways, in short, right, this is a situation to simplify. Yes, it's possible for black couples to have white kids and it's no one's fault. No one cheated and no one do any weird thing. It's just because recessive genes get paired up because both sides has recessive gene long time ago, in a few generations ago. Oh, So when you use the go on. Because when you use the word genes, right, then it's a bit difficult here. So are you referring to identical twins? Or okay, if identical twins, according to my understand, they are identical twins means that they both produce, both of the person is produced from the same zygote, and then one zygote splits to two embryos. So by that logic, both of their genes are identical. They will have definitely same genes. You look the same, everything will be the same. The only difference, there used to be an experiment called twin, I think it's called twin experiment. What was it? Okay, the twin experiment is basically they purposely put a pair of twins, and then one gets sent to space, one stays on Earth. They want to show long-term process of going to Earth. Does it actually cause any difference? Human twin study. Okay, let me see. Twin experiment. Oh no, this one is very scary. the Nazi human experimentation on purpose, right? Take a bunch of twins and then do experiment with them. One of the worst thing was, hey, since you guys are twins, right? Both of you have the same genetic, right? If I take the first person, cut in half, take the second person, cut another half, I piece together, will they still be alive? Yeah. Nazi do a lot of weird shit. It's like if you want, like, you know, creepy pasta and not sleep, and you're like, I can't sleep, and then I want to read something, I'll go on read them, you won't sleep. it's like, but it's all sorts of weird things. Twin experiment. You see, survivor twin experiments. Oh, wow. Let's read this. Nothing can prepare. Wow. The often sit. Oh, you see, you read this. This is the focus. At such a young age, so both she and her sister, they are twins. They will sit naked in a room up to 8 hours a day as blood was drawn from one arm and unknown substance injected to the other arm. So they want to see how the body reacts, and then they want to see whether injecting in this person and that person, given both of them have the same genes, will they have the same reaction. So it's all sorts of weird thing. And then the weirdest part was trying to sew two different genes to different twins together to create a, you know those conjoined twins where both person are born. They wanted to see whether they can form that thing. Yeah. If you are interested in very edgy stuff, there used to be a movie that a B-grade movie is where it tries to sew a bunch of humans up together. Yeah, it's very twisted. So yeah, just, you know, it's just weird. The twin experiment I want to show you was something to do with the space. NASA twin experiment. So basically, in NASA, they send one twin to goes to space, another twin stays on the ground, and then they want to find out after 1 year, 3 year, 5 year, 10 years as they grow, and then one until now still in space International Space Station, and one works on the ground in NASA office. How will they be different? This is considered one of the longest human biological experiment. Yeah, you see, Scott's telomeres become actually significantly longer. The word telomeres is basically some part inside the DNA. The longer the telomeres, the longer you can live accordingly. So they say Scott's telomeres. So the end caps of chromosomes that shortens as age. So basically this part is eventually we'll study that if you're interested in bio, chromosome has something called telomeres. Longer the telomeres is basically more DNA can be damaged and repaired back. So the longer the telomeres, longer someone's age. In other words, if they say Scott is the twins that get sent to the space has longer telomeres. Comparing to his brother, which is, according to here, I don't know what his name. Mark Kelly. So according to this, it seems to say that it says that although both are born with the same genes, because Scott spends most of the time in space, it seems like his telomeres are longer. It's like the body are spending lesser time to repair damage. Yeah, but go on. That's the concept of something called cryogenic sleep. Cryogenesis. Actually, cryogenic sleep, right? Okay, cryogenic sleep. Okay, cryogenic sleep. I don't think we have such a technology yet. For now, it's a pure theory thing. Okay. We want to talk about that. We have to link something called absolute zero. Are you familiar with the concept of absolute zero when it comes to temperature? Correct. The absolute zero is not 0 degrees C. It's actually negative 273.15 degrees C. No one in the world is able to achieve that temperature ever. No one is able. Because according to theory, if you reach absolute zero, they used to study kinetic particle theory. They say that all particles are in constant random motion. Means no matter how solid or how cold, something will still vibrate in fixed position. According to the basic way to explain this, the most simplified is when it reach negative 273.15, the vibration stops. The movement becomes nothing. You won't move at all. That also means that as if that particle get frozen in time. So if you freeze something at negative 273.15 according to the theory, and then you freeze it, you only unfreeze it 500 years later, and you unfreeze it, that particular atom will still behave as if it was 500 years ago. If you freeze something and then it stops vibrating, no kinetic energy, no changes, nothing will happen to it, you preserve it as if it was 500 years ago. And this concept was brought forward to the concept of cryogenic sleep. Is it possible to freeze the human body so that every single atom literally stop functioning and does not age, does not move, does not do anything, so that no matter how long time move, the body does not change? And as for now, cryogenic sleep is a myth. It didn't happen. Because the concept is that cryogenic sleep is once you freeze the body, then the blood will clot. That's not an issue, because you can still preserve the body by stopping everything from functioning and preserve the body. But once the body basically thaws, becomes warmer, certain part that is forming little ice crystals inside the blood, if it moves around, it cuts like a razor blade inside your body. Imagine going to the brain, then die. You cause a lot of damage. Yeah, so we don't know how to do that yet. So the closest thing we know how to do now is to freeze certain part of the body. Like for example, doing heart transplant, we freeze the heart part so that all the blood vessels freeze up, and then what we do is basically replace those freeze up blood with something else, like basically a replacement blood thing, so that during the freeze, maybe it's a good 10 minute or 8 minute, we replace, cut everything, shift the heart out, put it back, connects everything, then thaws and warm the heart back. That is considered very advanced technology for us to be able to tell the entire heart to stop, temporarily stop, change, and then restart it. Yeah, this is already quite crazy. So cryogenic sleep, if we can master this, I don't know, man. Maybe a bunch of people wants to be frozen up so that only the brain functions, and then you get linked up to a computer and literally play video games all day using your brain. That's pretty cool. Literally, you can live forever in that theory. Then you get Sword Art Online, lor. That's literally what it is, lor. You preserve the body, and then the brain gets to live in another world, and then you found a way to not die and forever live. As long as you can preserve the body, yeah. Which then that's definitely not something we didn't. Maybe our generation could build the basic theory, but it will not exist within our generation. Because humans still don't know how to tell a computer to interact with a brain. If you can do that, that's also education is also a thing of the past, because you literally can connect your brain to a computer and upload things. But using with the upload things then comes with new problem. What if I try to connect to your brain and then I go interfere with your memory? Then it's like, well, that's damn scary, because I can make you believe something that didn't exist, or something that you remember. I just click delete and then that thing gets disappeared from your life. So though there's a lot of argument on whether such technology should be developed. So yeah, so that's a bunch of things like that. So eventually, we can actually, if you are interested, we can actually talk more about the homozygous and the heterozygous, which is the dominant recessive, under chapter 19, heredity. That one actually links after the translation and the transcription. Correct. They have to teach you this first before you understand. That is, if the teacher effectively translate the idea of how genetics affect a person's feature, and then how that feature get passed on from one generation to the other. They should teach in that sequence after and clearly explain that part. I use this video because in poly I use this video to learn about this part, and this video has been along for like 6 years already. like actually it's longer than that, just someone uploaded to YouTube. Imagine that when I was poly was 13 years ago for me. So yeah, I know. So yeah, so I think that's pretty okay. So if you were to look at the textbook, if you flip from the thing, it just double check. It's 386 talks about genes, DNA, how they are related to each other. 387 talks about the phosphate sugar, how they form each little parts of DNA. Page 390 start to talk about something called codons, and how codons is linked to the first keyword, transcription, to produce mRNA. And then the mRNA goes to the ribosome, and ribosome do translation. And technically speaking, that's almost 80% of the whole chapter, which page 392 talks about the differences between DNA and RNA in terms of comparison. So it's not only just the uracil, the sugar unit that forms the backbone is different. One is deoxyribose, the other one is ribose, etc. So these are things that we have to take note, which eventually you can practice from 10-year series or some other questions which will link on, theories like this. Okay, page 393, 394, 395 has been tested before, that talk about genetic engineering. It basically says that if you can take a particular DNA and then you slice the DNA and then you link it, you form something called plasmids by taking another DNA from something else, then you cut and paste into it, you can make certain life form or cells perform different things. In this case, you can make the DNA to produce insulin, which insulin is used for people to solve diabetes. Because you cannot just, uncle sit down, auntie sit down. Yeah, you're here to sell insulin, right? Okay, here's a big needle, step into them and take insulin. It's like, then insulin will be either very, very expensive or very morally wrong. So if so many people need insulin, we have to take the insulin genes from people and put it into the bacteria and make the bacteria produce insulin. Of course, in real life, it's not so straightforward, because if insulin can be easily produced and everyone can easily make it and is safe to use, the company wouldn't make big money already. But if you can, do let me know. I'll invest in you. So 393, 394, 395, you can have some time read through. We can actually talk about it tomorrow, and once those are done, this chapter ends, because at the back it's just social and ethical issues of genetic engineering. It's a good discussion. We can talk about that. So for now, we can wind down. Okay, since now you know the general idea, I would advise you try to flip through and read through the textbook. Certain parts go through. If you can, then you understand, then skip. If the entire part you understand, then we can go straight after to the next part. If you're not familiar for a specific part, then we go through it tomorrow. I can explain it to you as well. Okay, so take some time, read through the textbook and see whether it helps. Okay, so any specific part that is not clear or you need some time to read through, or you have anything to ask? Oh, definitely. Definitely. There's something called a okay, I'll give you an example. Spider silk. You know what spider silk? You know the spider nest? And then they realize that you can use spider silk. You can make the spider silk into a piece of cloth. And then the spider silk will be stronger than a bulletproof vest. Yeah. Yes. Spider silk has this crazy toughness and crazy strength. You say a dragline silk. Okay, we read here, right? They say spider silk can be as strong as Kevlar. Basically, it can be as long as you have enough, and then you spin up together, you can use it to block bullets. So here comes the problem. If we basically, hey, spider, produce more silk, we die. we will collect the silk until don't know when. So how they produce silk is basically they put the spider gene inside a goat, and then the goat, right? Yeah, no. Don't worry. The goat didn't turn into a spider. Don't worry. They only take the genes of the spider silk. Basically, take the gene for the spider producing the silk, right? They transfer the gene into part of the goat to make sure that the goat produces milk that contains that protein. So you see, let me make this bigger. Spider silk-like protein extracted from the milk of the goat. So they put the spider silk gene into the goat so that they can produce that protein in the milk. So as long as you can collect the milk from the goat, and then you can basically collect a bunch of protein that makes spider silk, and then now you can actually put it into a machine to spin and to solidify to make the silk into cloth. And then this is something called biosteel. It's basically literally spider silk made into something that's stronger than steel that can even block bullets. Yeah. So in other words, the sky is the limit as long as you're creative, you know how to do, and then it's not illegal. Anyway, if it's illegal, then do it in like the China. Then I can do it there, yes. And then as long as don't get caught, you should be fine. Then you can make any animals do anything with this technique. Technically speaking, if you study biotechnology, right? And then your job and your optimized job is to be able to make something, produce something crazy good. Like for example, in China, they managed to produce babies that is I think it's called AIDS. It's not called AIDS. What's a virus that causes AIDS again? HIV resistant bigger brain. Yeah. In China, someone actually go against, this is under MIT Technology Review, so it's quite legit. So in other words, they try to CRISPR, CRISPR. CRISPR is a technique to manipulate genes of things. And then they basically manage to make children, because what happens is if the mom carries HIV, and the children will have high chance to get infected by HIV. So they want to find a way to change the genes of the children so that if the mom has HIV, the children are resistant and not get this. And they accidentally makes the children have bigger brains. In other words, smarter. So in other words, if they continue this research and they know how to, they can produce like superhumans with like smarter brains than any of us. And this is why things like this should be blocked. So yeah, there are like weird things, but then again, if that's why I say, if you somehow got into biotech and then somehow it goes like, hey, Mr. Lee, I'm like under traced by certain thing, and I did this, and then I managed to make big brain humans. I'm like, I'm in Malaysia. I have an underground. You might want to stay in there for some time, but meanwhile continue your research. You'll make big money one day. Yeah. So yeah. No one knows because it's like, you know, the place. it's 中华民国, so yes. So everything was covered out, everything was so-called said destroyed, but I don't think so. They confirm, you know, imagine they produce a bunch of people that are stronger, taller, smarter, faster, and then they become superhuman soldier. totally possible. Which, like, there's a bunch of weird things going on. It's secretive, and if you are a bio researcher, it's one of the best place to produce good results because they don't follow the law. Which the argument, if you know, do you actually know that the whole Jurassic World, Jurassic Park thing, the whole entire movie was based on a book, and the book was never about dinosaurs? Yeah, Jurassic Park and Jurassic World main thing want to discuss is they want to talk about situations where if scientists don't care about why they should do something and just do according to it, science will literally ruin humans. So in other words, if they just clone and make a bunch of dinosaurs, and then the dinosaurs are being made for all sorts of purpose, some people want it as pets, some people want to use it to fight war, and then if the dinosaur run loose now become part of our nature animal, literally it means you go out to the park and walk, and then a dinosaur can jump out. Then that would be scary. Then how do you control and stop the dinosaur from breeding? Then how do you control the dinosaur as a whole? So Jurassic Park is actually, or Jurassic World is a bioethics story actually. It's just that it's not as sexy as a bunch of dinosaurs eating humans. so because that was cooler, right? Dinosaurs killing humans, that's cooler than to talk over bioethics. So yeah, that's pretty much that. So tomorrow is Thursday and I still have time. Go through the book and see whether you find new things you're not sure. And if everything's okay, tomorrow let's cover the last part of the textbook and then we try some question to revise what we just learned. Okay? Cool. Then I most likely see you tomorrow at roughly about 7:38. Okay? Sure. Then see you tomorrow then. Okay? Bye. 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 Hey guys, I'll be right back soon. Yo. Hey. So. Okay. I just wait for the next person to ask me stuff. Hello. Hello, hello. Hello. You disappeared. Hey, you came back. Holy wow. Working, sleeping. Whoa, oh, there's like suddenly more work.
No, same one.
Wait a minute. You mean the new project? The half day project? Wait. Oh, I'm surprised. Because you say half day, I thought it would be like tomorrow half day. Mm, that's true. That's true. But I like getting paid later. Why get paid today when you can get paid later?
Wait. Oh, thanks for waiting.
Huh? Wait about?
Oh, I said you wait, and then you waited.
And then, but there's no elevator music.
Oh, we ran out of that.
Oh man. Oh, anyway, the stream is still on, so please don't speak nonsense.
I see.
Very interestingly, I don't know. When I'm reading it, do you think that AMD is trying to just push people to buy X570 motherboards, or they will release X670 eventually?
You mean right now or?
I don't know. It's like the whole trying to discontinue, but there are people who say that previously, right? They are like AMD says that we will not support this, and then the motherboard manufacturer just goes like, oh no, it works, but it's not optimized, but it works. Our board is good enough, so here's the BIOS upgrade, and then they got very angry.
What, AMD or?
AMD told the board manufacturer to just discontinue. Board manufacturer updated the BIOS and still support it nonetheless. They claim that it won't be optimized, but can you so?
Oh. Well, I'm very sure AMD would be upset because
It's like sell more boards, man. Why you support this old thing?
no, okay, that while that is one thing, I think the biggest reason why they're upset is because yes, it will still be working, but it's not optimized,
And
which
then
means
you
that it will
affect performance.
well, yeah, they already say it's not optimized, right? So if it doesn't, if it's not optimized for performance, it means that their future numbers will drop. Like benchmarks, the things that are giving them so much confidence will drop.
You
there's
mean people will be so irresponsible and say, hey, I use the old motherboard chipset and then I run this latest thing and then the thing is so shit, and then they will do that?
I don't know. They might.
I guess.
Plus, it's not like they have full control of people's news consumption. So
You have a point. Hard to say, right? People just, or people can run a bunch of smear campaigns or all that thing.
yeah. So it'll definitely be upsetting for them if things like that happen. Especially after like they set up like such a big gap between them and Intel, right? All needs to be pulled back by something like this.
I don't know. I think generally it's just enthusiasts. It's like after reading more, let's just say I understand that my PC is pretty imba in a general sense.
General.
You know, I always thought that is like an acceptable spec for a working PC. So
General.
No, I'm just saying. I just like okay, cool. I guess it's really something.
Your computer is really something. Like I'm very sure I have mentioned it before.
It's like you let any teenager to own the same thing. Wow, they will like drool at the mere specs of it and the things you can play and do with it.
It is.
They're like, wow. I'm like, but this is not the highest. That's 3950X. That's 2080 Ti.
Sure, but that's not how.
But even if I buy those, I don't think I will be using it for now. I wouldn't use the maximum potential of it for, unless I'm doing like VR streaming. I'm teaching VR, right? Then that's different, you see.
Like even for VR.
If you are doing VR, you're recording and streaming at the same time, and also run VR. Hard to say. And at the same time, you're running 4 screens, and one of the 4 screens, one is 1080, 2 is 4K, and 2 is 1440, and 1 is 4K.
Okay, then you're just changing the parameters of the.
Yes, because whenever you talk about computer builds, you have to talk about what things you want to use it for. If you say you want to do game, what games, at what screen, at what refresh rates, and at what settings.
While that is true, most people have most people have a mid-tier sensibility when it comes to like these kind of computer builds. Because yes, there are enthusiasts who wants to do everything in once. There are professional entertainers who wants to do everything on one computer. But those are not most people.
Fair enough. I will accept that.
Because right, if you have your kind of setup with four screens and 2K on 2 screens, one 4K and one 1080 with VR and streaming and recording. I think at that kind of like build, right, you're better off buying 2 computers.
Like one for running the VR, one for doing all the encoding and streaming, right?
Yeah.
Then you basically don't buy 2 computers. You buy a special case and you build 2 systems in it.
I mean, you can, but why?
because save space and it's cool, right?
I don't think save space works that way.
But if you see such a thing where you'd go like, whoa, that's pretty cool.
Well, definitely, it's definitely something. About the practicalities.
Yeah, you just have to have a big tower and then it runs both things. You know, on top of that,
What?
because cooling is not enough, you build custom loop to cool both things.
Like, I mean, I can appreciate that, you know, that kind of like setups are impressive. Like, definitely is impressive. But it was me, I'll have three CPUs stacked on top of each other and call it a day.
3 CPUs stacked
on top of each other and I'll call it a day.
This is why I get to do R&D and you get to control the R&D going crazy.
I see.
You are like extremely rig everything to the max, you see.
No, I'm just not as excited about extreme experimenting.
Then eventually might as well I just empty out a room and set up a server rack, right? And then pipe and then start building, I don't know, some optical fiber in my room to pipe information to that thing, right?
Sure, but why?
You gonna tell me that when you're in your 50s, 60s, and then you have the ability to do that, you wouldn't want to try? And then you have your own house already. You have your own house already. Your entire house has like 5 rooms. Okay, make it 10. 10 rooms then.
Wow, if I have that kind of house, I'll sell the house to buy a 3-room flat.
What? No, no, that was wrong. That was the wrong direction in the first place. It doesn't work like that.
Okay, no, but okay. Ignoring the house, sure, if I have that kind of, ability to spend on equipment to tinker, definitely, I think it'd be fun. People do like build servers as a hobby and have like a server room for their own use, whatever that may be. And it's like fun to like tinker. Well, at my current level, the only way to do that is through running multiple Raspberry Pis.
It doesn't
And
work
AWS.
like that. Multiple Raspberry Pi.
Yes and no, actually. So, because each Raspberry Pi is a computer, right? Technically, that's like one server. If you have a proper setup to link all of them together into like one cluster, you can do that with any server. You just upgrade the equipment.
Fair enough.
Oh, but that would be fun. Running your own cables, right?
I actually know what you would do. You said that if you have the money, you'll buy a NUC. When it comes to NUC, it's really something.
Yeah.
And it's also super impractical at the same time.
But yeah, definitely. There's a lot of things that you're giving up when you get a NUC.
Which are?
Things like upgradability, things like control over the thermals, and how much control you have over your hardware. You're giving all of that up for space saving.
Space saving.
Because it's really space saving. Like imagine, right? You have a monitor, like a nice big one. Maybe not as big as yours, but.
We are on stream. Don't mislead people to think that my monitor is very big.
Your monitor is really big.
No. Everything's relative, you see.
Okay, how many inches is your monitor? Diagonally.
All the exits are sealed. Shit. It's 34 inch.
Is it?
Yeah.
Oh.
It's not that big, you see.
Yeah. What's the screen ratio?
Huh?
What's the screen ratio?
1:1.
Whoa, that's a very big monitor.
1:1.
Oh, what are you running a control center? What's such a weird monitor?
Every time I watch movie, the lion go. It got really scary. It's like huge.
If you watch a movie, right, on a 1:1 monitor, your screen will be really small.
Why?
Because most of it will be black bars.
Yeah, that's true.
It's a 16:9 movie in a 1:1 box.
You
Right?
go to Samsung, you insist that you want a 1:1 custom make. They still be like, but why? It's like, I don't care. I got the money. Can you make it? Yeah. I mean, it's not that we cannot make it. We can, but But why?
Oh yes, but why, right?
And then after the meeting, they will just talk behind my back. So, you know, people with money got no brains. Very weird.
1-to-1. Very strange. I do like the. Okay, like. 4x3, right? It's like
Yeah,
the old
4x3.
aspect.
Yeah.
4x3 is like. It's like okay. 16:9 is like. I think it's a bit too long. I think 16:10 is not bad. Just you get a bit more height on your content.
Because for me, it's when I work on Excel spreadsheet, 16:9 is cool. You can see so much more on like the site.
Mm-hmm.
And when you run like WhatsApp and when I answer questions from students and everyone is like spamming, reading vertical things, that's perfect. You can see so much more. And that is the reason why I have a 34 and I run a vertical 27-inch. And that's pretty much it. And everything has its own purpose lah. That's what I'm trying to say.
I like how you say that's pretty much it so matter of factly.
I only have 3 screen plus a drawing tablet. I only have 3 screen.
You only have 3 screens. One a 37-inch, one a 27 is it? Vertical screen.
27.
One auxiliary one, and one Wacom screen tablet.
In theory I got one 34-inch horizontal ultra wide, one vertical 27-inch, another one also vertical 27-inch, and then one Wacom 1080 drawing tablet. Only like that? Only what? A lot, man?
Like that only. Do you want to know what's my monitor?
Hey, don't complain. You choose not to use the monitor. You use it only for dedicated Animal Crossing.
Yeah, because I don't have space on the table. But okay, well, nonetheless, even so, I would have 2 screens. One of them 24-inch, one of them 21.
We will change that soon.
No, absolutely not.
Why not?
No, I do not need more screens.
Oh, you mean you need new real estate before you need the screen? Yeah, okay, that can be arranged.
I see.
Hey, how do I climb you? No, I'm trying out Splatoon, but I cannot climb the wall. Angry.
Climb the wall? Oh, you need to spray the wall first.
Is it? Oh. Then become a fish.
Squid.
I have squid, fish. Who's like counting, right? So don't worry about it.
Wait, I need to clip this.
Oi, no, you can't clip it on YouTube. It doesn't work like that. Hey, wait a minute, there's a delay. Holy, hey, no. Hey, 我们有话好好说 please. I need this career, and I can also nego a price to have your career covered. So please. Yeah, please.
So that's how we're going with.
Yeah.
Do you buy Splatoon?
Yeah, I have. I mean, Splatoon is the first game that I played with you on the thing.
Splatoon 1, is it?
No. Splatoon 1 is on the Wii U.
Oh, I see. Oh man. 2.
Oh my god, that's how it works? Okay, that's pretty cool. I'm actually pretty bad at this.
Are you playing online?
I'm playing one player because
Oh, campaign.
yeah, because this game don't give me To play. I think we used to do this goose mode or something,
I think so.
and then we are like pretty bad at it. Do you still play this? I don't think so, right? It's not your game style.
No. My sister played it the most, so I didn't play it. FPS is fine. FPS with controllers a bit hard. It's very, but I do like Splatoon because it's on Nintendo.
Yeah, you don't die. You respawn after that.
Okay. In most deathmatch formats, you always respawn after you die because it's called a deathmatch. So
No, when you're killed, you are not dead. You want to kill it until it dies.
I see. People die when they're killed.
Yeah, people die when they are killed. That's so deep, you see. Don't you think so? That's so deep.
It's very sad. Do you know what the original line is?
No, I have no idea.
It was the okay. So the context is something about the dead people being raised back to the living and used as slaves.
So
Or-
basically, dead people should stay dead.
Yeah. It's just a really poorly translated line, so
Well, how you know that I should spray the wall in order to jump?
I played multiplayer for a while ago.
Oh, you're quite smart, huh? r/I am very smart.
You know that line always reminds me of that one comic strip about society.
Which one?
The one where there's a peasant saying we must improve society somewhat, and then like some guy on the side popped up, and he says, and yet you participate in society. I'm very smart.
Is there such a thing?
Wait, let me find the meme.
I learned r/I am very smart from Reddit.
There it is. Oh, okay, it says I'm very intelligent. But it's the same, I guess.
We should improve society somewhat, yet you participate in society curious. What does that mean? I don't understand.
A person who noticed issues with society comments that, we should improve society somewhat. And then some guy on the side mockingly says, and yet you participate in society. Saying that the I am very intelligent part is like a mock. It's supposed to be a self-mocking thing. Because like there's a lot of people who go like, oh, you are complaining about these issues, yet you still participate in it. So yeah, yes, that's why they're commenting on these issues, right?
If you don't participate, how do you comment?
Yeah, exactly.
I don't understand the logic.
So these group of people think they're like they are very intelligent because they're commenting on these kind of like stupid observations. They're supposed to mock these people.
That's so weird.
No, it's a. You know how internet macros is, right? And that's how people on the internet communicate nowadays. I'm sorry, not internet macros. Internet memes. That's how people communicate nowadays, right?
Don't think I ever understand that. And that's for my good of my mental health then, I guess.
I don't know whether that's.
Collectively, we are actually quite a sad species. And when I use the word sad, I'm referring to most of us are unhappy. And it's actually a very I don't know. Has it always been like that? Or I don't know. I'm just not sure. There is an estimation that says will one day, like, you know, depression reaches a critical level, given with the assumption that depression is what do you call this? Depression is, do I use the word transmittable? Can be spread from a person to the other. And with that assumption, will we reach peak depression, where most of the functioning people becomes depressed, and then over time the species fail to function as a society? Such a scenario has been explored actually. You do know the theory that people says that you know, where when people excessively speak using memes, can turn into this scenario of expression of depression, right? Can lead to like a symptom of depression, right?
Yes.
People speak of memes because more than often most memes talk about the hopelessness or the futileness of us trying, and you make that out and then you mock that, turn that into a mockery.
I mean, there are memes of that topic, yes.
And those are called depressive memes. Yeah, and then they're actually quite popular on the internet. And the excessive use of that makes people get used to the process of complaining the problem or without facing the problem and thinking how to solve it. That's not good. That's in my opinion. It's not people cannot. It's you can, but after all that complaining and whatnot, what would you do, you see? Yeah. I don't know. Unless someone tells me that what I can focus on, to me is, if not focus to, you know, make things better, then what's the purpose of living? I'm waiting for a student to come in 30 minutes.
Hmm.
Mm-hmm.
Hey guys, Buildzoid here from Actually Hardcore Overclocking, and today we're going to be taking
Welcome back to Harbour Unbox. Today, we are finally getting our first proper look at MSI's new X570 Tomahawk motherboard, and as you guys probably know, I've been very keen to test this thing out for many months now. And this is a very important motherboard for MSI. Not only does it mark the next step in their X570 redemption tour, but at $200
Oh no,
US,
oh no.
it's a board.
What?
No. I need to. It's fine. No worries. Yeah, don't worry. It's fine. I'm just reading stuff. Interesting. No, people complaining that they're having difficult time in poly. They're saying something like 7 projects and quiz in 1 month. Immediately I have 6 projects, and now I have another 4 projects. In other, he says that he has 17 projects, 1 quiz, 2 major exams in 1 semester. And then he says that then by that logic he will have 34 projects and a few major exams in 1 year. In my head I'm like, but you only have 2 major exams. And it's a business course, so I don't know. Yeah. So I don't know. In my head, that means that they chose poly because they heard that it was easier. Yes, because the title says that they say year 1 was the easiest. I don't know. Because I would say that the workload for JC is pretty crazy too. Yes, so in other words, it's I don't know. You know my I guess maybe because my principle in life is whine less, do more. Soft finish first, then you whine. It's fine. Don't whine it because it's not helpful. You can whine all you want, nothing's gonna change. Because in my head, projects sometimes their markings are a little bit more qualitative than quantitative. It's not like you get this correct, you get this score, you get A, you get this score, you get B. So in theory, as long as you know how to do well, you can kind of score better, right? Okay. No, I don't know. All I know is that if you give me project, then I'll just tell the teacher, give me matrix. What's your marking matrix? Then I will do my things according to the matrix. That's how you get scores, right? That was in uni actually. I just got in. And then I have to Poly doesn't have scholarship. Poly mainly has the book prizes. You have to get in and then continuously win the book prizes, which is like 2K, 1K, 500 kind of thing, then stack up to pay for your next semester. No. There's no such thing as a scholarship through Poly. The main thing you can only get in is basically through what do you call this? A tuition granting. And then after that, every semester you work well. At the end of the semester, you win book prizes. And certain book prizes are meant for international students where you work harder, you get that, and that covers your next semester's school fees. Mm-hmm. Mm.
Where it's like, okay, yes, things are, I mean, things are stressful. Yes.
Mm.
You know, once you get out of it, then suddenly poly sets a very different. There's a lot of things that you need to cope with. It's a change of environment. It's a change of environment. It's a change of studying style. And then it's the first time you're given like some form of like freedom to decide for your future, which a lot of people abuse. You know, because for a lot of people that's like the first taste of freedom they get. So when they say, oh, they're very stressful, they feel stressed during second year, see why.
It's first year, right? First year, it's not even second year, first year. And this first year, I don't know. I cannot comment because I didn't go through business school. Because in my head, it's like chemistry with the sheer amount of both math and, very technical subjects. I don't think business has a lot of reading, I know, but chemistry has a lot of reading too. And it's like, I went in a triple science course, so I don't know. I guess, but then again, I get it, right? When I speak to you about it, I guess what you want to tell me straight is basically, people are not like you. You can't think that if you can do it, why can't people?
I mean, there's a lot of different options, right?
I agree.
Plus, all these, I mean, like, for us, we know that, when we rent, things don't go anywhere. Whereas all the time can be dedicated the most to creating solutions.
To me, is if you want to rent it with the right people, so that to me, it's like if you rent to I was brought up in a situation where rent doesn't solve problem. If you ever want to open your mouth, better make sure that the person you talk to and the things you say gets you help. Yeah, that's my criteria of opening my mouth.
For me, I think for me it's a bit different. Like, I can't really rent
Yeah, but you do know that as your friend and someone who cares, I want you to talk about things like this so that I know what I can do to help. And you know the feelings when you are friends and then you realize that your friend has a problem but he didn't tell you, and then deep down inside you're like, is this a friend? Is the friend treating me as a friend? If so, why he doesn't want to share his problem with me? You know that feeling?
I mean, yes, I understand that kind of like. It's not that I don't want to tell you if I have any issues. It's just that I'm not used to it. I never had for a very long time. I had no one to talk to about anything.
Okay.
It was like primary school, secondary. It's like I'm very much alone
Mm.
in every aspect. Like, even the teachers, I have no one to talk to. And so I'm like very much alone. In the class, I'm known as the guy who don't talk to anyone. So much so that, okay, maybe I shouldn't talk about that. Never mind. I shouldn't talk about that.
No worries, it's fine.
No, not really, it concerns other people. So.
Mm-hmm.
No, the thing was, I'm just not used to talking to people about these kind of things. Because, I had no one to turn to, and now that I do, I'm not used to it. And for a lot of people, that might be how they feel too. It's just that now people are more used to the internet now, so they are more willing to shout into the void of the internet,
Mm.
hopefully to get a voice back somewhere. But you know, internet's a void.
Mm. Is it called DM or PM?
Either is fine. I think DM is more of a Twitter thing.
What about Reddit?
Yeah, but like,
I don't know. Because I I don't know. Maybe I mean in this very weird position that I'm being brought up in such a way that I'm not allowed to whine. So it annoys me when people whine, I guess. But then again, the other day I was watching some YouTube show thing, and people did say that a psychiatrist did say something along the line that humans generally don't grow up until they are like 25 mentally. They say until you are like 23, 24, 25, you are still people still behave pretty much like a child. So I guess I have to realign my standards, I guess. I don't know, my way of handling things, do you think that I'm more of a cold hard calculator?
Sometimes, but I don't think it's just the situation you grow up in. Certain, like all of us have like lived through certain harsh realities, right? There's just different degrees of.
To me, the fed up that I've been through so many situations in my entire life, that everyone is talking, everyone's making noise, but no one is solving things. Everyone just like stand, in like class, right? Everyone just stands and go, yeah, situation very bad, no. Yeah lor, sucks man. I'm like, yeah, all your mouth are moving, but I don't see you moving, solving anything. Why are you complaining then?
Well, being complained. Okay, that people do complain. Because it brings them certain relief, knowing that other people are suffering too. That they're all in it. They're all in this certain situation, and for one, they feel that they're not being unfairly treated, and two, maybe they might feel a compulsion to make the system better for everyone.
Whoa. That's a very big claim. What do you just said that? I don't think that works.
No, I said maybe.
No, I largely don't believe in that. Majority people only their mouth moves. Nothing else follows that. At least I'm referring to people that I'm exposed to in this part of the world. People complain all they want. Once the complaint, and then once that I use the word, that pain get eased by a bunch of people literally licking each other's wounds and say, oh yeah lor, 我们都很惨咯, yeah. And then as long the anxiety fades away for that day, then procrastination. Another day, oh, it builds up again, come back, whine, rant. Okay, now it's okay. Then okay, another day, and just rinse and repeat.
I mean, yes, while majority of the people feel have helplessness in that case where all they're doing is licking their wounds, there's some people when noticing this kind of pattern may step up.
And yes, and yes, and those people do not have time to whine and complain. They only whine and complain after the problems are solved most of the time. Then they will say how bullshit that situation was. Or they did something, they tried something, then their complaint and whine is like they did this, and everything fails, and then they get angry, and then they want someone to calm them down and encourage them to move on. That's different. Complain to people just at the first sight of things and talk about it. That's a bit, just say, not my style.
Yes, but to assume that all of them, just to assume that most people only complain without action is
Do
I don't know.
double consider what you see
Mm-hmm.
in a majority sense. I'm not saying absolute, huh? I'm saying majority.
Mm-hmm.
I'm making the assumption based on probability.
Okay.
Yes.
Well, alright. So, majority of the people just want to complain because it gives them some form of relief.
And where does that relief leads to? Whether that some form of relief is okay. I'm okay with that.
Mm-hmm.
What's the follow-up?
But what about in social? What about in stricter social societies like Japan, where people are not allowed to complain?
Mm-hmm.
I mean, in those situations, people suffer more, I suppose. I don't know. Okay, like what I'm saying is the act of complaining is not necessarily a bad one. I mean, yes, a lot of complaining leads to inaction. Like definitely, majority of that one, I agree that majority of the people who complain have no follow-up.
Mm-hmm.
For them, it's an action of pain relief for the moment.
Mm.
But if they are not allowed to complain, then
No, don't get me wrong.
Mhm.
I'm not saying that people are not allowed to complain.
Mhm.
I'm just saying that if all people wanted to complain, it's a sign of relief, and then that's the end of it. That's not good. That's a difference.
So should all forms of complaint lead to action?
Complain means there's a problem, right?
Yes.
So if complaining means that you don't want to solve the problem as a follow-up action, means that you want someone to solve it for you, right?
Mm-hmm.
That's.
But what?
Mm-hmm, go on.
Okay, so what if they don't want? I mean, what if? Okay, they do want someone else to solve it in that case, but I don't know whether if that would be most people's intention, knowingly at least. or is it that when people complain without action, their knowing intent is for someone else to fix it?
It's an implied thing. To me, in my head, it's like if someone complained about something and someone just say, okay, that sucks, man. That's really bad. But then, if that's the case, what's your plan? How do you follow up from here? If the person have a plan, good. This person wants someone to, unload those trash and then move on. That's fine. That's very respectable. He's just being overwhelmed by problems and he still wants to solve it. It's just too much. That's one now. That's a perfectly good thing, because if you don't do it, then you go crazy and then you can't follow up. But it's the latter that people only complain and don't do anything and come back to complain about same problem, same thing, same time. Just many times, same thing, same complaints. That doesn't sit well with me. Or rather I grew up to expectation to not expect someone to come down to save me. I don't have that savior mentality. I actually detest that kind of behavior. But majority of people do subscribe to that kind of thinking. And there are experiments that talks about helplessness is not a nature state. You know about that, right?
Oh, I'm not.
Naturally, there's like happy, sad, fear. Things naturally, there's no such thing as helplessness. Helplessness is a learned behavior. It's not a behavior that exists in animals naturally when they are born. So if a person goes through this helpless situation, something has take away control and power from them.
So in that situation, would it be themselves? Would it be an external factor? Would it be...
It's very complex. There can be many things. But in the very general short explanation is there's no sense of agency. The person either don't have or what's even worse, don't want to have control over their lives. But it's like saying someone wants to make all the decisions, but generally humans in life is they want to have all the control, all the decision, but none of the responsibility. That's I admit there could be extremely biased of my view on that, but generally that's what I believe most kids are. Up when I use the word kids, it covers up to the age of 20, 21, 22, 23. So that's my view.
I think a lot of young people, they do not understand what responsibility means, because it's not really taught to them.
And that is actually why when people like this, places where many of this age people congregates, it gets extremely toxic. For example, video games. I'm not blaming on them. I'm just saying that I don't know. I don't think education teach that. I think that's a parenting thing.
Yes, I think so too, because half and half, I think.
School can only teach you consequence, societal consequence. And it's not an academic thing. It's an indirect thing where you do something, people can literally punch your face. And you do something wrong, you need to know how to handle people and diffuse situation. But Maybe actual education tries to explain to you in words in a logical format so that it slows down and then you can follow the changes and follow the dynamic thoughts of certain cause and effect, I guess. Through like moral studies and stuff, I guess.
And I don't think it's just moral studies. It's more like everyday classroom behavior. If you are in an educational where it's like extremely hostile, right? Where every mistake you make is severely punished without explanation, right? Or at least portrayed as such. It was like back in primary school. I had this like very bad teacher.
Okay. Pause. Hold on to the very bad teacher. I have a student calling. Let me
Sure.
join. Hello.
Hello.
Hey. Okay. Before I turn old and forget, I need to faster explain to you.
Huh?
Before I
Can
turn. Huh?
What are you saying?
Before I get too old and forget about the explanation, so I need to explain to you first. Actually, the questions, if you really look at it, that's quite easy to solve. I think we overthink it. So.
Why your cat can blink eyes, one?
Oh, so right. Wait. Let me mute you. Okay, cool. No, because I'm every day from 8 to 10. I'm sitting in a stream. So I'm for any students to just come in and ask questions. And on stream, I don't want to use my face, so I use a cat. So as I move my head and as I talk and as I open my eyes, the cat moves with. Yes. Yeah. So basically, I want to use the cat as me. Yeah. Cool. So eventually, imagine that a cat teach chemistry better than teachers. Okay, never mind. Go on. So yes. Okay. This question that you see on screen. Okay. I checked already. When it's normal boiling point, it actually translates to 1 atm. So yeah, normal boiling point should always be at 1 atm, and then if you were to calculate it, 1 atm is 101325 pascals. So it's like 100,000 pascals. So compared to 1 and 2, C is definitely higher. Then you basically calculate D, and then answer is higher, right?
Yeah.
That's not true, because water at 50 degrees is not gas. If it's not gas, you cannot use ideal gas law to calculate. Yeah, it's a trick. Yeah, so if I don't know whether your A levels covered that, then if you want to calculate the pressure, you have to use something called saturated vapor pressure to calculate D, and definitely the pressure will be like 30. I think it's 30 or 32 pascals. It's like very, very low. Because that one requires thermodynamics, which is like a advanced uni thing. It's like older. But if you do learn about it, I'm not surprised, because you RI ma, so they always teach extra thing. Yeah, but it's just a school, but I think that the teacher and the support system and the general culture is actually quite okay. You hang out with the right group, it's quite a nice school to hang out. Your friends are what? Too well? Yeah, but how party can you be? I mean, you can party, but after that you will wake up in the middle of the party and like, shit, I need to do revise. Then you go back and you'll be fine. Don't worry. So yeah. Okay, so question 11 solved. Question 14 is actually According to my other students from actually from the same school, but I don't know whether but R is a huge school anyways. Jeremy, I don't know, but he goes by Jeremy. I only know his Jeremy, but I don't know what's his entire full name. But then again, how many class you have? It's like so many other class, right? And he takes further math. He didn't take chemistry, so he takes bio. Yep. I met him online and I just helped him. In short, I helped him and somehow he managed to did well for O levels and he's in RI now. So yeah. Water polo. I'm not sure. I double check with you. I double check with him about that, but I don't think. I don't know. Is he hot? Okay, again. I see. Got what they call this? Got eye candy or not so far? Oh no. Wow, so mean. Maybe I stand that very high. Okay. This one is from Hua Chong. Any Hua Chong question, right, is always twist and turn. So this question, right, the other time you asked me, so we only know that pressure and volume, the curve goes in like this, right? Like this, right? What's your explanation? So because as time increase, volume increase. So in other words, I can remove this into time. So that's why answer is C. So there's no special relationship. It's just that they on purpose says as time increase, volume increase. Then purposely they put time. It's actually what they wanted to represent is use time increase to represent volume increase. So it's just this time can just be rewritten as volume because it says increase at a constant rate. So time increase, volume increase. So it's just a trick. So it's literally a typical thing. If you don't understand and you only memorize things from textbook, you say, hey, cannot find they only have pressure, volume. We go to have pressure time graph. Okay, because as time increase, what happened to volume according to the question? Yeah, because increase at a constant rate. So they use time to trick by removing the concept of volume. They use time because the question already tell you time increase, volume increase. So the textbook, you will never be able to find a pressure time graph. If you Google, you will also never find a pressure time graph because the question tells you time increase with volume increase with time. So that's why no matter how hard you Google, you can't find. Yeah. So far, okay, all soft, right? I think it's further math, physics. Yeah, he's very dedicated to detail, not like someone that doesn't care about physics. But yeah, that's what it is. Oi. You don't like about the detail, but you can remember things very well. So you do well for bio. Yeah, but your physics is like you work really hard for it. Yeah, and turns out well, and then you drop it because you don't like it, and it's fine. That's your preference. Yeah. Then what about chemistry now? Is it like, are you coping well? No, that's good. Until organic chem, then let me know how it goes. Oof, why? Yeah, but you have, I don't know, you have like other teachers? Okay. I mean, to be honest, yeah. Okay, so in general, Monday to Thursday, 8 to 10. I will literally sit here, so bother me as much as you want. You can call me on Saturday and Sunday. I'll still be having classes, whatnot. We can just store up a bunch of, yeah, because, but right, got special privilege. Okay. The pressure. The pressure. Oh, you mean the volume changes ones? You can just take both and minus and then you get it? Really? Okay, let me look at it. Question 26, is it? The two vessel, is it? Sorry, you don't have V for which one? Huh? Student asking me stuff and because I literally like tell my student and say if you other students want to just come and ask, feel free, I don't mind. In fact, if you have other, your friend very party, so yeah. Which one? Question 26, huh? Okay, let me bring it up. You cannot get the answer. You said just get the pressure and minus and then you get answer? That sounds like a challenge. Challenge accepted. I'll do that. Okay. Yeah, no need to find V. We can remove both sides. Huh? What? Okay, you see. PV equals nRT, right? Then you already, yeah, basically both side V can be removed by dividing away, but just which V? I didn't write a V? You got it? Okay, let's leave it as that then, I guess. Then okay, I mean, you're having vacation now, right? You're having vacation now, right? Huh? What do you mean? Oh, do you use the app that grow a tree one, or it's just a how? But screen time is so sad. Oh, okay. There's an app that basically every time you don't touch, the tree grows. The moment you touch, then the tree dies. And that's pretty cool, I would say. You can. You see. I send you. You see, Malaysia got this. Really? Oh, so you now order all the bubble tea store, is it? Yeah, which is the whole lemon, I don't know what is it called, the whole lemon peel with the white pearl. What? Huh? Ray don't like the black pearl, right? It's the white pearl only. Then what she drinks when people order bubble tea? Then what thing from Liho? Just between me and you, I think it's a good choice. That to keep yourself away from trouble, that's a good thing. I finally understand why you sometimes a bit, let's just use the word cold-hearted to your sister, to your younger sister, because you know, stay away from trouble. That's a very smart move actually. I take back what if I ever said that you are troublesome, I take back what I said. That was when before I met Ray, so I'm sorry. So now I met Ray, I know what true trouble feels like now. So huh? I mean when I met you, you're a lot more mature, and then you talk sense and stuff. I mean, yeah, sometimes you have the emotions, yes, but Ray is a total different thing. It's like a primary school kid, man. It's like very hard to talk sense. It's like, oh my god, I don't know. I think you're more out of the bunch, you're the most rational, I think. Yes, that's what I think. But yeah, like for example, Ray keeps fighting with the youngest at home now. It's like, why? Why? What happened? Actually, what happened is like, she whines a lot. I don't know, it's like too much whining. my head hurts. I'm like, can you like concentrate? Okay. Bye bye. No problem. Hey, I'm back. Oh no, you disappeared. Never worry, I think you're working. Bye. Pity. Pity, 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 pity. Hello.
Hey, Sarah.
Hey, masa. Doing well?